Hello everyone, welcome to the video on organohalogen compounds. This is NCERT Chemistry 12th class Unit 10 of Haloalkane and Haloarenes. This video series is made according to NCERT syllabus. All the concepts and key points are explained in detail. While going with the video, you can take screenshots for a brief notes. Now in this video, I will explain haloalkane and haloarenes application and uses, classification and nomenclature. This is my YouTube video channel. You just type in my name G Sai Rajesh, you will get my channel details. Now in this series I will be covering the entire NCERT organic chemistry concepts. Let's get started. Now when you see the unit 10, under the title you find this statement. What does this says? Now according to this, halogenated compounds persist in the environment due to their resistance to breakdown by soil bacteria. What does it mean? See, it means halogenated compounds persist means it stays for long time. They stay in the environment for the long time because they are not breakdown by soil bacteria. It means you know about plastic. Plastic are not degradable. They stay for a longer period of time on the soil, and that is what causes major pollution. Halogenated compounds also kind of soil pollutants because they are not degraded or breakdown by soil bacteria. So the statement inference is these halogenated compounds, when they are in the soil, they may cause soil pollution. Now organic halogen compounds can be classified as aliphatic and aromatic. Aliphatic one are known as alkyl halides or haloalkanes. Aromatic one are called as aryl halides or haloarenes. You need to be comfortable with this nomenclature. Aryl halides, haloarenes, both of them are same. Alkyl halides, haloalkanes, both of them are same. Now how do they form? They form by replacement of one hydrogen from these compounds. When this one of the hydrogen is substituted with a halogen, you get haloalkanes. Similarly, in aryl compounds, one of the hydrogen, when it is substituted with a halogen like chlorine, you get chlorobenzene. They are called as haloarenes. So this is the basic classification between aliphatic and aromatic halogen compounds. Now clinical uses and application. See, all these things are given in a NCERT book. As I told you, the videos are made according to only NCERT syllabus. Now first two are industrial applications. What are they? Organic halogen compounds can be used as solvents for relatively non-polar compounds. Understand this. See, when you perform a reaction, you need a solvent in which all the reagents are dissolved. For polar compounds, water is the best solvent. Whereas organic halogen compounds are good solvent for relatively non-polar compounds. Understand this one. For polar compounds, the best solvent is water. For relatively non-polar compounds, organic halogen compounds are best solvents. Next one. They are very good starting materials for the synthesis of wide range of organic compounds. So they are used as a starting material for organic compound synthesis. So these two are industry oriented applications. One, they are very good solvents for relatively non-polar compounds. Two, they are good starting materials for many organic compound synthesis. Now the next one are clinical applications. Chloramphenicol is an antibiotic which is used to treat typhoid. Thyroxine is a hormone which is synthesized in human beings which controls metabolism. The deficiency of this thyroid hormone may result in a disease called as goiter. Now when you see this, both of them, chloramphenicol, thyroxine, are naturally occurring compounds. Chloramphenicol is obtained from a microorganism. Thyroxine is naturally synthesized in human beings. Both natural compounds has got important clinical uses. After that, you have drugs like chloroquine, which is used to treat malaria. Halothane, used as an anesthetic during surgeries. These two are synthetic compounds. Look at these points, how they are framed. Two of them are naturally compounds given, examples for that, and two of the synthetic compound examples are given. Finally, blood substitutes. Some of the halogenated organic compounds like perfluorocarbon can be used as blood substitute. It is still under research. Now understand, what do you mean by this blood substitute? What is the function of blood? It will carry oxygen. Now these perfluorocarbon can also dissolve oxygen and carry oxygen. So it can be used as a blood substitute in future. Because it is under research, it may be used as a blood substitute. So all these are clinical applications and uses of halogenated organic compounds. Moving further, now classification. Now classification is based on number of halogen atoms. If only one halogen atom is there, it is known as monohaloalkane. If two are there, it is known as dihaloalkane. If three are there, trihaloalkane. So this is about haloalkanes. Similarly, you have haloarenes also classified according to the number of halogen atoms. Monohaloarene, when two atoms are there, dihaloarene. When three are there, trihaloarenes. Now in monohalogen compounds, again the classification is based on the bond, whether it is sp3 carbon or sp2 carbon. See, halogens, we have fluorine, chlorine, bromine, iodine. All of them are halogens. Now let us understand the classification in this one. See, all here a halogen is attached to a sp3 carbon. sp3 carbon. Now in this again methyl halide. To methane a halogen is attached, it is called as methyl halide. Now then comes you have primary, secondary and tertiary halogenated compounds. Understand this nomenclature. Primary carbon is a carbon to which one carbon is attached. Secondary carbon is a carbon to which two of the carbons are attached. Tertiary, to this three carbons are attached. And to this carbon a halogen is attached, hence it is known as tertiary halide. Here it is secondary halide, this is primary halide. Understand this one, methyl halide will not fit into this category. You say primary when one to this carbon another carbon is attached. In methyl halide it is only one carbon is there. So it will not come under primary, secondary, tertiary. After that, depending upon the number of carbons attached to the halogenated substituted carbon, it is considered as primary, secondary and tertiary. Now in case of now see. Now next one is allylic halides. Now you need to understand this group. There is a group called as allylic carbon. Now this carbon is known as allylic carbon. So this is what is allylic carbon. When the halogen is attached to allylic carbon, again here this carbon hybridization is sp3. So they are known as allylic halides. Again similarly here, look at this one is carbon, double bond carbon, and then one more carbon is there to which a halogen is attached. So this is also sp3 carbon. So in sp3 carbon you have classification like primary, secondary, tertiary, and then allylic halides. When the halogen is attached to allylic carbon, it is called as allylic halides. The next one is benzylic halides. Now look at this is a benzene ring. When a methyl group is attached to benzene ring, it is called as benzyl. When the halogen is attached to this benzylic carbon, it is known as benzylic halide. Again to this carbon only one carbon is attached, hence it is primary. When do we call secondary? When this carbon has got one more carbon attachment, it is called as secondary. If two carbons are attached, it becomes tertiary one. So understand this one, primary, secondary, tertiary, and then allylic carbon and then benzylic carbon. If the halogen is attached to allylic carbon, it is allylic halide. If the halogen is attached to benzylic carbon, it is benzylic halide. Now, see all these things we have seen, the halogen is attached to sp3 carbon. Now, sp2 carbon. Now, vinylic is only carbon, double bond carbon, and to this. So, this carbon is vinylic carbon. So, this carbon is called as vinylic carbon. Understand the difference between allylic is 3 carbon 1, vinylic is 2 carbon 1. Now, vinylic halides, so this halogen is called as vinylic carbon. Now here both the carbons, the hybridization is sp2 carbon. So these are related to sp2 carbon, halogen is attached. Similarly aryl halides, look at this, in benzyl to a benzene ring a methyl group is there and to that methyl a halogen is attached. In case of aryl halides, directly the halogen is attached to sp2 carbon. sp2 carbon. So these are known as aryl halides. So this is about sp2 carbon halogen bond. Now in NCERT there is no word about sp carbon and halogen bond, but for your information, when you have a triple bond and halogen attached to this carbon, these are known as sp carbon and halogen bond. These are known as alkynyl. So there is no word about this one in NCERT books, but understand this one because we are reading about sp3 carbon halogen bond, sp2 carbon halogen bond, and this one is sp carbon halogen bond. Moving further. Now, after this classification, we need to know about nomenclature. Nomenclature, let me give you some of the important points. See, whenever you name according to IUPAC, first we need to talk about substitution and its position. So look at this, there are 3 carbons are there, so this is propane, and a bromine is a substitution. So the substitution carbon will get priority. So at first carbon you have bromine is there, hence it is known as 1-bromopropane. So first we talk about substitution and then parent. What is parent chain here? Propane. What is substitution here? Bromine. At which position the bromine is there? At first position. So this is called as 1-bromopropane. Now here at second position halogen is there, so 2-chloropropane. Now here see the parent chain is the longest chain, 3 carbon one. At first carbon you have a chlorine substitution, at second carbon you have a methyl substitution is there. Now look at here, you have 2 substitutions are there. When you have 2 substitutions, the substitutions are placed according to their alphabetical order. So C comes first, then M. You have chloro substitution is there, you have methyl substitution is there. Now chlorine alphabetically comes first and then methyl. So hence we talk first about chlorine and then methyl and then the parent chain. Similarly in haloarenes, when a bromine is attached to benzene, it is called as bromobenzene. When 2 benzenes are there, you give places and then you say 1 and 3 bromobenzene. Here 1, 3 and 5 places bromine is attached, so 1,3,5 tribromobenzene. Now again look at this one. See, the longest chain is taken and to the first carbon chlorine is there, and then at second carbon 2 methyl groups are there, so it is called as 2,2-dimethyl propane. Now understand this one. See, when you have such kind of substitution, you need to consider the alphabet of M, not D. It just says 2 methyl groups are there, but what is the substitution? Methyl is the substitution. So after C comes M. You should not consider D for priority, it is only the substitution. Now again at second position bromine is there, so it is 2-bromopropane. Now next comes interesting groups. Now look at this. On 1 carbon 2 chlorine substitutions are there. It is known as 1,1-dichloroethane according to IUPAC. But the common name is also important one. So these are called as ethylidene chloride or ZEM dihalide. Understand this one. See, the compound is like this, CH, and 2 chlorides are there. Now they are called as ZEM or geminal dihalides because when you see in 3-dimensional, this appears as ZEM. Gemstones will be in this shape, hence they are commonly called as ZEM dihalide or geminal. Now the other one, 2 substitutions are present on 2 neighboring carbons. They are known as ethylene dichloride or vicinal dihalide. Vicinal means neighboring group. In IUPAC it is simple, 1,2-dichloroethane. You need to understand what is meant by geminal, what is meant by vicinal, and commonly they are known as ethylidene is for geminal, whereas ethylene is for vicinal. So these are all the important aspects. Now finally some of the common important halides one. See this one, let us see the IUPAC name. At second carbon you have chlorine is there, so 2-chlorobutane. Now compounds like this, in order to name them, you need to write them completely, then you don't have any confusion. See, on 1 carbon you have 3 methyl substitutions are there. This is the carbon, 1, 2, 3 substitutions are there. Now look at them. This is the longest chain, propane, 1, 2, 3. At first position you have bromine is there, at second position 2 methyl groups are there. So 1-bromo, 2,2-dimethyl propane. Now similarly the next one. Again on 1 carbon 3 methyl substitutions and bromine is there. On 1 carbon 3 methyl substitutions and bromine is there. Now in this case you need to choose a longest chain one. So you can choose like this. So carbon 1, 2 and 3. At second position you have bromine is there. At second position you have a methyl group is also there. So this is 2-bromo, 2-methyl propane. At second position bromine, at second carbon you have methyl group is there. Now after that you have this vinyl group. This is what is vinyl group is. Chloroethane. Chlorine is there. Ethene. Ene indicates a double bond. Now then this is an allyl group is there. So commonly it is known as allyl bromide. In IUPAC wise 3-bromopropene. Ene indicates a double bond. Now these groups orthochlorotoluene. See, according to IUPAC, multiple names are possible. This is one of the example. See, in one nomenclature it is known as 1-chloro-2-methyl-benzene. This is 1-chloro, this is 2-methyl. Again, substitution alphabetical order wise named. Or you see benzene with methyl is toluene. So this becomes the first position, and then the next one is at second position you have chlorine substitution is there. Don't get confused when you are talking about two substitutions, alphabetical order priority is given. Toluene, this carbon gets priority and this is the first position, and at second position you have chlorine substitution is there. Now the next one, this is benzyl chloride, chlorophenyl methane. Chlorophenyl, this is the aryl group is known as phenyl in IUPAC, and a methane is there. And then this is dichloromethane. Two chlorines are there, methane is there. And then chloroform, trichloromethane. On single carbon, all the substitutions are there. This is tribromomethane. And then tetrachloromethane. Four chlorine substitutions are present on carbon. And then 1-fluoropropane. This carbon is taken as 1, and first carbon you have fluorine is there, and then propane is there. So this is about nomenclature. So this is about classification, nomenclature and applications of halogenated organic compounds. In the next class I will explain about how haloalkanes or haloarenes are synthesized and what are the reaction patterns. Thank you for watching this video. If you like the video, do subscribe and share.